Hello everybody. This is a little demonstration of coming up with an average mass and using that average mass just like we do with atoms in chemistry. I'm going to use paper clips. So what I have is an element called paperclipium, PC. It comes in two flavors. There are the small paper clips, PCS, and the large paper clips, PCL. And I've done extensive studies on paperclipium, and I've found that the small paperclipium is 65% of all the paperclipium, and the large is 35%. So now what I'm going to do is I'm going to take the mass of each of these. So we have here a large paperclip, and the mass is 0.96 grams. So let's write that down, 0.96 grams. And then we'll do the same thing with a small isotope, the small paperclipium, and the mass is 0.42 grams. All right, so we can actually calculate the average because if you remember, the average is the percent of A times A, the percent of B times B. In this case, the average paperclip would be the percent of the large times the mass of the large, plus the percent of the small times the mass of the small. So the percent of the large was 35%, and the mass of the large is 0.96. And the percent of the small was 65%, and the mass of the small was 0.42. So that means the average paperclip is, drum roll, 0.65 times 0.42 would be 0.61 grams. Now what's interesting is if I reached into this pile of paper clips, would I ever pull out a paper clip with a mass of 0.61 grams? And the answer is no. I'm either going to pull out a large or a small, and so it should be 0.42 and 0.96. But what good is that average, the 0.61, if the average paper clip doesn't exist? And the answer is, in chemistry we have this problem. And the problem is that we want to be quantitative. We want to know how many atoms are in a sample. But we can't count atoms because atoms are very, very small, too small to see and too numerous to count. But what we can do is we can count them by weighing them. So I'm going to take these paper clips, I'm going to put them on the balance. And the balance says that we have 12.58 grams. So we say 12.58 grams, all right, using dimensional analysis times one paper clip for 0.61 grams means I should have about 20, it comes out 20.6, but we'll round it, so around 20 paper clips. All right, so if I get 19, 20, 21, all right, so I'm going to count these out. Let's do it. 1 paper clip, 2, 3, 4, 5, 6, 7, 8. I know the suspense is killing you. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 paper clips, all right, between there and the one that got stuck in the side. So you can see, even in this small sample, counting by weighing worked. And of course, the bigger the sample, the more important the average is. So there you go. There's a very simple demo that you can see how we can use the isotope and the average atomic mass to count atoms by weighing.